Ladies and gentlemen, please take your seats, and we'll get things underway. A mere 6 minutes late. It's not so bad now, but later on we have to try to adhere to the program, and this is my bad for starting us off a little late. There are still people arriving, and so we gave them a few extra minutes. Welcome to the beautiful city of Quebec and to the 18th Astronautics Conference of the Canadian Aeronautics and Space Institute. Mesdames et messieurs, bienvenue à la belle ville de Québec et à la 18e conférence en astronautique de l'Institut aéronautique et spatial du Canada, ce qui est très difficile à dire si on est anglophone. Mais me voilà quand même. My name's Jeff Longadoc, and I'm the Executive Director of CASI, the Canadian Aeronautics and Space Institute. My role is to ensure that your experience at Astro 18 satisfies all your expectations. Please don't hesitate to bring to me or my staff in the registration room any questions or concerns you may have. So right now I'd like to take a couple of minutes of your time to run through the program for today in the nature of a housekeeping type of presentation. So first of all, our president, Jacques Giroux of ABB, will be doing the formal welcome, and he will be moderating the two panels we have this morning. Between 10 and 10:30, we'll have a coffee break, and then following that will be the Canadian Space Agency Directors General panel, and the 4 CSA DGs are here with us today. Lunch will be on your own today and tomorrow, so either you can eat in the hotel if you wish, or within a 10-minute walk, either along Grande Allée or some other streets nearby. There are lots of places to eat. Please don't go too far because you may not get back here in time. On an institute note, between 12:15 and 1 o'clock, CASI is having its annual general meeting in the Montcalm room. That's on the 3rd floor. And all members of CASI, or would-be members of CASI, are welcome. We'd love to see as many people there as possible. Then at 1400, the 6 breakouts begin, and they are all located but one on this floor. And the Wolf Room, which is one of the breakout locations, is on the 3rd floor. So anybody who's in the Wolf Room for the session you want to go to, it's on the 3rd floor. The day concludes with the Astro 2018 welcome reception with hot and cold hors d'oeuvres being passed. It's what you'd call a heavy reception. So it may not be enough for dinner, but it'll tide you over. And there'll be a cash bar. Wi-Fi connectivity exists in all the rooms. And for those of you for whom this matters, the Wi-Fi password is Astro18, ASTRO18. Like on an airline or an airplane, I'm required, because we've been in the air for more than 5 hours, to advise you about where the emergency exits are. So out through those doors, and right straight ahead, you'll see a CASI logo. You go through those doors and you're outside. In the event that that whole wall is in flames, you can get out this way through the back of house. You'll find your way. Hopefully it won't be too smoky back there because the hallways are kind of tight. One final word, please mute your cell phones so that we don't have talks being punctuated by bells ringing. So it's now my pleasure to introduce our president, Jacques Giroux. Dr. Giroux obtained his PhD degree in instrumentation for nuclear physics at Université Laval, and that was followed by a postdoc at the Max Planck Institute in Heidelberg, Germany. Many of you will have gotten to know Jacques since he joined ABB 27 years ago in 1991. So for many of you, Jacques will be the face of ABB, certainly for me. At that time, ABB's space activities were in their infancy, and Jacques had much to do with their development in the intervening years. His experience at ABB spans business, management, and engineering aspects of optical instrumentation for remote sensing and Earth observation. Ladies and gentlemen, please welcome Dr. Giroux.
Thank you very much, Jeff, for the kind words. So it's a pleasure to welcome you all to this 2018 edition of the Astro Conference. organized by the Canadian Astronautics and Space Institute. Il me fait plaisir de vous souhaiter la bienvenue à tous à cette édition 2018 de la conférence Astro organisée par l'Institut aéronautique et spatial du Canada. CASI is a great organization, and it's very special to me to be taking on a one-year term as its president here in my hometown of Quebec City. Je suis très honoré d'entreprendre ce nouveau rôle pour la CASI, et ça me fait grand plaisir, et j'espère bien servir les intérêts de CASI durant ce mandat. We have a very good program ahead of us, and I believe you will appreciate it. We have a program made of several plenaries. We will be starting these this morning. We also have a very strong technical program, and I would like to thank very much the organizers of the technical program committee, especially Christian Lange from the CSA and Mick Faragalli from Mission Controls Space Systems. Maybe if you can both stand up so that we can know you. So that's Christian over there. And Mick is there. Thank you very much for the work. And also they were supported by a long list of volunteers that help setting up the program and motivate people to submit abstracts and all that. So thanks to everybody for that. So I think that being said, sans plus attendre, we will move on to the first plenary, the title of which is Perspectives on the Future of the Canadian Space Sector. So I would like to invite the panelists to join me on the stage.
Do you want this in a particular order, Jacques?
Maybe the order we decided we would speak. So maybe Sylvain, Mike, Ewan, and Kaylee.
I don't remember the order.
Take this one, ça c'est moi. Oui. Merci. So let me introduce each of the panelists. So we'll start with Sylvain. So Mr. Sylvain Laporte was appointed President of the Canadian Space Agency in March 2015. So more than 3 years ago, that starts to be some form of a longevity.
Have I been fired already and I don't know yet?
Prior to this appointment, Mr. Laporte held various positions in different Canadian government organizations, including the Canadian Intellectual Property Office and the Industrial Technologies Office at Industry Canada. Second panelist is Mr. Mike Greenlee, who has very recently been appointed, in fact in January this year, as the Group President for MDA, one of the Maxar Technologies company. Mr. Greenlee, prior to this appointment, Mr. Greenlee served as Sector President for L3 WESCAM and Vice President and General Manager of CAE Canada. Mr. Greenlee's responsibilities include all of MDA lines of business and its 1,900 employees in Canada. The next panelist is Ewan Reid, the founder of Mission Control Space Services. Prior to this, to founding the company, Mr. Reid held various positions at Neptec Design Group. And the final panelist is Miss Professor Kaylee Walker, so Professor of Physics at the University of Toronto. Professor Walker has over 15 years of experience in atmospheric remote sensing. She began work on the CISAT ACE satellite mission as the calibration and validation scientist and became deputy mission scientist in 2006. So for this panel, we will basically start by, I will be asking each of the panelists to provide introductory remarks covering the activities of its organization and how they relate to space, and then, depending on the case, but talk about general trends affecting the organizations or changes in your organization, things like that, to set the stage for further discussion. So we will go one by one, and once this is done for introductory remarks, we'll go with 3 specific subject or questions that I will be asking them. So we will start right now, and I will ask Sylvain to say his first introductory remarks.
Okay, merci beaucoup, Jacques. Is my microphone on?
Turn the button on.
It is on.
Okay.
Am I being heard all right? It is on. It's on? Okay, good. Got the thumbs up from the back, so I guess I'm okay. Bonjour à tous, puis bienvenue à Québec, certainement une de mes villes préférées. Donc, happy that you're all here in great numbers. Jeff mentioned this morning that we were starting 6 minutes late. From a few of you this morning, I heard that we actually started too early. Many of you found it difficult to come to our conference at 8:15, but glad that you're there. So I'm Sylvain Laporte. I'm the president of the Canadian Space Agency. And in the space world, hopefully here in Canada, the Canadian Space Agency is well known. And I thought I would skip a bit of the introduction of what the Space Agency is. But I did fly from Gatineau to here yesterday and met some great people in the airplane, in the taxi. And a few of them never even knew that we had a space agency in Canada. So that kind of made me rethink my idea of an introduction. And not only did they not know there was a space agency in Canada, but they actually thought that we were currently on Mars and that we were breathing oxygen on that planet. And that we didn't need, any kind of equipment to be there, and probably we had cars and whatever else on Mars. So I don't know what planet these people came from, but certainly not the same that I belong to. So it was kind of an interesting conversation and quite revealing. They had, I guess, a ton of questions with respect to space. So all that to say, just a few words with respect to the space agency. We have about 635 people at the agency. Most of them are located on the south shore of Montreal, in Saint-Hubert. But we do have a few offices in Ottawa, in Washington, in Paris. And we do have a laboratory, the David Florida Laboratory in Ottawa as well. Our mandate is about the peaceful use and development of space. And for that, we do a lot of missions, and we do a lot of science. So hopefully that kind of wraps it in terms of describing what the space agency is about. Because in my introduction, what I do want to convey is that these are very exciting times to be working in the space field in a number of areas. And when I look at all of the areas of responsibility where the agency is involved, I don't think that none of them are not under a lot of change right now. So it's a very dynamic environment. Very glad to be part of all of the discussions that are happening, not just in Canada, but worldwide. So this is not a Canadian agency or a Canadian phenomenon, this level of very high dynamics. It is an international phenomenon, and because it's international, the momentum there is likely to stay for a long, long time. And what I mean by it being a very dynamic environment, if you look at a few examples, so just talking about space exploration, for example, we are looking at some very interesting and creative discussions with respect to going to the moon and Mars. The project is becoming more and more tangible with the nomination of Bridenstine at the head of NASA. We're now seeing a number of decisions being made. We're seeing progress wanting to be achieved as quickly as possible on that front. So it's moving the rest of us in the partnership in a rapid way. So we're seeing a lot of evolutions there, and some of the designs are now starting to take shape, starting to be finalized, starting to be approved by the various committees, the various standards discussions as well. So that's moving forward, and we're very, very interested in those discussions, particularly with respect to what Canada could contribute to such a program going forward. So as you know, we've issued a number of RFPs over the last 12 to 18 months to help us understand what Canadian capabilities exist today so that we can make the best pitch possible to the government with respect to a potential probable contribution for Canada to these endeavors. So that's exploration. When I look at other pillars of our mandate, Earth observation is something that we're very, very strong on as well. And we're seeing a lot of developments in the remote sensing, Earth observation kind of fields, particularly with respect to a lot of the commercialization activities that are ongoing over there. So we've got quite a number of private companies that are putting up or looking to put up some satellites up in space. So that's really going to change the environment for the various national governments because it's going to provide some more options than us having to put our own satellites in space. So a lot of interesting developments in that area. And of course, I'd be remiss if I didn't speak about the LEO SATCOM or the advent of the LEO SATCOM initiatives that are being worked on by quite a number of companies internationally. And I think that the great majority of the folks that don't live in a major urban area are going to welcome these new technologies in a few years from now. And I can speak from experience. I live in a town called Chelsea, which is only 20 kilometers north of Ottawa. And I assure you, I cannot watch a Netflix movie without seeing the dial tone. And it gives us a natural pause to go and get some more chips and Coke. But it gets to be a bit frustrating that close to civilization and not being able to watch a movie without it being interrupted because of very low broadband reception where I live. So you don't have to be up in the north. In fact, some people in the north get better service than I do. But you don't have to be very far from a large city to get pretty awful bandwidth. So I'm personally looking forward to the success of these LEO SATCOM initiatives. And I'd like to just conclude with what we're seeing in terms of activities at the Space Agency in 2018. We've already launched our NanoSAT competition. So, 15 NanoSats are going to be launched. Some of them are going to be done in collaboration. But there's going to be a NanoSat launched by every one of the provinces in 3 of the territories. So we've actually managed to get the 3 territories to collaborate and to commit to delivering a NanoSat in space. These NanoSats are all going to be launched from the ISS, and we've purposefully tailored the program to ensure that this was all driven by the students and with their university professors, so that we can get the most hands-on experience possible out of this. So this is what we call capacity building in Canada. So hopefully after this, these students will find a way into our Canadian industry or our Canadian universities, and they'll be able to brag about having put a satellite in space and having designed and built and developed these satellites. So this hands-on experience will be quite valuable to the future employers. So hopefully that will be quite helpful. We've also ensured that we gave them just enough funding to get them committed, but not enough that they can only rely on the government money, because we do want to bring in the entrepreneurs in them. We do want to give them the opportunity to go out there and to market what they're working on and to look at raising some additional funds and having conversations with the various business people out in their hometown. So, this idea of an entrepreneurial scientist is very strong with us, and we need to develop those skills in those engineers and those scientists. So part of this exercise or part of this program that we launched is also looking at refining those skills for them. So then we've got David Saint-Jacques, who is launching to the ISS. He will be launching now on the 20th of December for a 6-month plus mission. So looking forward to David's launch and to a lot of the experiments that he'll be conducting on the space station. He has about 258 odd experiments that he's going to be personally involved with. And you can imagine that we are going to, just like the astronaut recruitment program, we are going to have a massive communication and outreach campaign that is going to go with this. We want to bring a lot of pride in Canadians to have another astronaut on the ISS, and we have a ton of planned activities for students and teachers in school. So this will be a very profound, very intense outreach program for us, and we hope to have a major impact on Canadians as we go forward. And then we've got the NanoSAT Constellation mission to be launched in the October timeframe. So equipping Canada now with 3 new state-of-the-art Earth observation satellites with all of the bells and whistles that comes with that in terms of ground stations and an ability to process this data. So 2018 is going to be a very, very busy year for all of us and for Canada as well. Thank you.
Okay, thank you, Sylvain. So we'll now turn to Mike for his own introductory comments.
Okay, good morning. As mentioned, my name is Mike Greenlee. I'm now the group president of MDA. In terms of just an update on our organization, for those that aren't aware, and I've kept track of all the changes over the last little while, MDA is now part of a company called Maxar. There's 4 strong companies that are part of Maxar, which include MDA, which includes Digital Globe, Space Systems Loral, and Radiant Solutions. So that's about 6,500 people now in a space company doing about $2.5 billion a year of business. It's a pretty exciting place to be these days, to be part of that, to be part of a group that is building satellites, is building ground stations, is putting missions into orbit and operating them, has a large services business now that's doing analytics for Earth observation. We have about 1,100 personnel in Radiant Solutions that are inside government agencies in the United States providing analytic support to all their missions and operations and geospatial intelligence every day. And so it's a very good group to be together, to have a full end-to-end solution, vertically integrated, available for the international space market. Back here in Canada at MDA, MDA is MDA. I'm the president of it. It remains a Canadian company doing business in Canada, employing Canadians and exporting from Canada, and paying our taxes like good Canadians should. We get just enough money out of the, how did you say it? Out of the Canadian government to be committed, but not enough to run a business. So, so we will continue to be entrepreneurial and seek exports worldwide from here in Canada. In terms of trends that are affecting our business these days, I think all the same trends that Sylvain was mentioning definitely affect us. We have significant opportunities in Earth observation. We're very proud to be part of the RCM launch this year and finishing that project and delivering that capability to Canada. But at the same time, when you have those large government programs and those opportunities, then you see the rest of the up-and-coming commercial base that's coming out in the new space economy, which we'll talk a bit about this morning. And dozens of opportunities to adapt those technologies to partner with and work with all kinds of different sizes and shapes of businesses that are now trying to find their way in space. Same thing happens with us on our ground stations business. We have historical ground stations in over 20 countries around the world, which are typically large, multi-source ground stations that started their journeys with a strong life in GEO. But now the opportunity is much more vast in terms of adapting those, scaling them down, making them more accessible to a wider audience and a lower price point and new business models so that all the range of startups and activities going on in LEO can then work with us and still access through different business models that new ground station technology. So we're having to adapt to that. The whole shift from GEO to LEO and the proliferation of activities in low Earth orbit for Earth observation and comms in our satellite subsystem manufacturing business is causing adaptation there. So where we might have grown up a very strong engineering and manufacturing capacity here in Quebec and Montreal, for that satellite market. It grew up in the day of GEO programs where you would have customers you could count on two hands around the world, and you would build components for 1 or 2 or 3 maybe satellites. Now we're contracted on OneWeb, for example, for that constellation in low Earth orbit where there's 900 satellites, and we're building 1,800 antennas for 900 satellites. So that's a dramatic shift in terms of the manufacturing capacity that we have to step up to in Canada. So we're using a lot of increased, fourth generation industrial capacity, advanced manufacturing, increased use of robotics to be able to assemble high precision, high volume satellite components and participate in those markets. So that's a trend that's really affecting us, in addition to our ground station shift, which would be ground stations for tasking, multi-source GEO satellites to now managing and resource managing full constellations in LEO. I think the on-orbit servicing business, which people have talked about for over a decade, and from what I've seen, is on the verge of coming into its own. The acceptance of that as a concept, that there would be various forms of satellite and spacecraft put up to go and service satellites, to be able to make repairs to them, fix problems, refuel them, reposition them, deorbit them. There's a solid list of expectations there in that market space. And I've seen, even in my short time here, the number of conversations globally of people that would like to talk about, especially proven space robotics on commercial on-orbit servicing platforms, dramatically increasing. And so I really think that that's going to kick in here the next couple of years, just based on the number of conversations and their maturity. So which causes the same shift as we're seeing in other stuff, that transition from historically large institutional government programs to more commercial activity that we see in satellites. You even see it in space robotics, where you could kind of grow up in the world of Canadarm and shuttles and space stations, but now be adapting that for a commercial sale to another firm that wants to run a business doing on-orbit servicing. We're keen to hear continued remarks on space exploration that Sylvain was mentioning. That's obviously of key interest to us in the world of robotics and deep space stations and rovers and lunar habitation and moving on to Mars and communication networks for that. So all of those programs are interest to us worldwide, in Canada for sure, but also internationally. I think that's the other thing that we see as a trend for us, is the international pull of the number of countries that what I call now have space ambitions, but not past proven space performance. So for us to have 50 years of space experience in Canada, those nations that now have ambition, that see the economic benefits of participating in this new economy that's in orbit around the Earth, and they want to get into the game, they're very encouraging and welcoming for those of us that have that kind of experience to show up and participate in their neighborhoods, in addition to, of course, being strong supporters here at home. That's our situation.
Okay, thank you very much, Mike. So Ewan, your turn to present your own organization.
Thanks, Jacques, and thanks for the opportunity to be here. And for all of you in the room that did make it out here pretty early, as Sylvain pointed out, I think that's a sign that despite maybe a bit of a lack of political support for space in this country right now, that there's still a lot of excitement in the community at large. And if Sylvain starts off his talk with how excited he is with his opportunity, then I think we all should be excited, because he's in a pretty tough spot. And I think I'm excited. I think it's an exciting time for engineers, for scientists, for business people, for explorers. I think Mr. Musk and his counterparts are rapidly changing the established paradigms. And in doing so, they're making even more ambitious plans seem credible. So I think, like many people in this room here, I was down at the IASC, the International Astronomical Congress in Adelaide last summer, and I saw Elon present his plans as to how they were going to pay for the BFR, the Big Falcon rocket. And I think what struck me most about that presentation and that day wasn't the fact that there were thousands of industry VIPs, lining up for hours to see him, but that as soon as he was done and everybody walked back outside into the sunshine, all anybody was talking about was the timelines and when is SpaceX going to make it to Mars, and is this timetable too aggressive, and what about that part, it won't be ready. And there was zero discussion about whether or not it would actually happen. It was just a matter of when. It was taken for a given that SpaceX was going to Mars. And I think that had he given that exact same speech to those exact same people, even 3 years before, he would have been laughed out of the room. But when you've successfully launched and landed something like 20 first-stage rockets in a row, you've now developed a credibility and people believe you. And that's really important, not just for SpaceX and other companies in the US, but for all companies that are doing space activities, especially the new space startup kind of companies. It gives us credibility and it gives us opportunity, and it lets people buy into what we want to do. So it's really changed everything. And it was somewhat in anticipation of this almost new space age that Mission Control was founded 3 years ago by a group of, I guess, excited young space professionals, myself and two others that are in the room here, Melissa and Kaley, and a few others. And Mission Control is a space exploration and robotics company. Our focus is on spacecraft operations, onboard autonomy, and artificial intelligence. And we're working to develop a full-stack robotic control solution. So everything from embedded systems to help spacecraft operate more autonomously on their own, to user interfaces to facilitate remote teleoperation. And our technology is designed to increase the safety, the efficiency, and the usability of spacecraft, and ultimately the scientific return of missions. We're also committed to inspiring the next generation of explorers to pursue fields studies in STEM through our immersive Mars simulation experience, the Mission Control Academy program. So we've delivered that program now for full 3 years since we've been in existence. We've delivered the program to students on 4 continents and ranging in ages from about 10 or 11 all the way up to postgraduate professionals. And we really look forward to the day when students across Canada, from every community, and really all around the world, can turn their classroom into a rover control center and get the opportunity to feel what it's like to operate a rover on Mars, or almost on Mars themselves. So Mission Control has benefited from the support of the Canadian Space Agency, both in terms of procurements, but also through grants under the Space Technology Development Program, which has been critical for us in terms of gaining an early foothold in the industry. And in kind of startup parlance, I'm used to saying that Mission Control is a pre-commercial entity. But it seems like I'm going to have to update my terminology these days, because we've subsequently been able to commercialize some of these investments that we've received from the CSA, and that we've now sold our technology both to companies here, organizations here in Canada, but also south of the border. And that's really exciting for us because that represents a commercialization of the commitment and investment that Canada made in us as a young company, and really demonstrates that we have a solid future to be able to keep growing. So this panel is about perspectives of the future of Canada's space sector, and I was specifically asked not only to consider the perspective of Mission Control, but also take into account and represent, I guess, the perspectives of the smaller, newer, commercially focused space companies, so maybe the space startups. So before I came here, I reached out to Mina Mitri, the CEO of Kepler Communications in Toronto, and James Sleifertz, the CEO of Skywatch, and asked them kind of their opinion, so I would be able to come into this discussion with more than just a space exploration perspective. And I think Kepler and Skywatch fit pretty squarely into the trend of new space that we've been seeing grow now for some time south of the border, where the majority of new companies have a value proposition related to either Earth observation or telecommunications, and rapid growth is sought, enabled by external investment. And so the early success, at least in terms of financing, which to some degree is a measure of success of new companies these days, of Kepler and Skywatch is a confirmation, I would say, that the Silicon Valley style of new space has arrived in Canada. It is here. And more and more often I hear other positive news related to new space companies in Canada. I've heard that the Creative Destruction Lab in Toronto, which is an established entity that helps innovators transition science projects to high-growth companies, is going to be starting a space stream to attract 25 new space startups to Canada. This organization, not only supported by VC and other experienced players in the Silicon Valley market, is also supported by Chris Hadfield. So there might be some music as well as money making going on. And I think that that's going to facilitate the arrival of some smart money. So investment that comes with the expertise to help build a large-scale company and evolve and grow from a small group of founders or startup into that sustainable business. So I think that these and other market forces are going to continue to drive the advancement of new space throughout the world, as well as in Canada. And whether it's in telecoms, EO, exploration, companies like Kepler, Skywatch, and Mission Control will continue to strive to grow and prosper. I think the big unknown that I see is the role of government and how the government plays in this new space future, and what decisions they take, and how that will affect how our companies operate, and how we whether or not we choose to stay here, and how we choose to pursue our opportunities. And hopefully, that as an introduction can lead us into some good discussion between the four stakeholders we have up here, who I think do represent really diverse range of industry and the sector at large. And I'm looking forward to seeing what everybody else has to say.
Thank you, Ewan. I think you set the stage for some of the coming questions. So I'm now turning to Kaley to provide his own introduction.
Okay, and now for something completely different. As Jacques mentioned earlier, my name is Kaylee Walker. I'm a professor in the Department of Physics at the University of Toronto, and my area of expertise is atmospheric science. Primarily, I focus on building instruments and making measurements of atmospheric composition from a variety of platforms, particularly using satellites and high-altitude balloons. One of my main jobs is being the deputy mission scientist for CSA's NanoSAT mission, and also I've led 2 balloon projects funded by CSA. The latest one, to build and fly a laser absorption spectrometer, we're scheduled to launch this August, and that's what the team is doing back home, getting things ready for vac testing this week. I've been involved in space exploration in the didn't quite get to Mars instrument MATMOS, which was to fly on ExoMars 2016. And also I'm involved at more community level as the external co-chair of CSA's Atmospheric Science Advisory Committee. Now, compared to my colleagues on the panel, I find it a bit more difficult to introduce my organization's space activities, as I'm here supposedly to represent all of academia. The academic community in Canada is involved in many aspects of space research and development in this sector. I could start off by telling you that my university is the largest in Canada, and we have 70,000 undergraduate students and 18,000 graduate students. But that really doesn't give you a sense of what we do in space. It's not quite the right metrics. So I'm going to tell you a little bit about my view of the community. Notably, we're incredibly active in Earth observation, including atmospheric physics and chemistry, Sun-Earth system studies, and Earth system science. So that's getting down to looking at land, oceans, and ice. We're also very strong in planetary science, space astronomy, and aerospace engineering, as well as the areas of life sciences, microgravity, and I'm sure I've forgotten some things, and please forgive me for offending those whose areas I haven't highlighted. Our experience in the academic community spans the full cycle of mission development and execution, from starting off from concepts, instrument and science development, through testing, operations, and utilization. So definitely, Canadian academia is not homogeneous in its interest nor its involvement in space. So at this point, to avoid being too general from here on out, I'm going to use my own area of atmospheric physics as a basis for my perspective. So within the area of space-based atmospheric science, we currently have 3 Canadian satellite missions that are led by university teams providing information on our planet to the community at large in Canada and internationally supporting both science and assessment and policy activities. The oldest of these is MOPIT, measurements of pollution in the troposphere, that's flying on NASA's Terra satellite. It's launched in late 1999, survived Y2K, and is still providing us with excellent global measurements of carbon monoxide and how this pollutant is transported around the world. Next is the OSIRIS instrument, the optical spectrograph and infrared imager system on the Swedish Odin satellite, launched in early 2001. OSIRIS is providing us with key multi-year measurements that are needed to understand the recovery of the ozone layer and the influence of aerosols in the upper atmosphere. Finally, the youngest of these, and the closest to my heart, is CISAT. Carries the Atmospheric Chemistry Experiment, or ACE, was launched in mid-2003, and it provides measurements of more than 50 different species in the atmosphere. This is the most that have ever been measured simultaneously from space on a Canadian platform using Canadian instruments. These measurements have allowed us to track changes in greenhouse gases, ozone-depleting substances, and pollutants in the Earth's atmosphere for over the past almost 15 years. The operations centers and data processing and validation facilities for these missions are based at the University of Toronto, University of Saskatchewan, and the University of Waterloo, with data exploitation being undertaken at more institutions across Canada and around the world. Now, I hope you will note that these missions are now into their teenage years, getting a little bit cranky, but still performing well, and they range in age from 14 almost to 19 years of operations. So this brings me to my first point in the general trends influencing our work in academia. When MOPIT, OSIRIS, and CISAT were launched, they were to last between 2 and 5 years in order to address specific science questions. However, during our extended lifetimes, the focus has moved from having a one-off satellite mission to address a certain set of questions or specific question to using satellite measurements to build long-term data records to monitor and understand the Earth's climate. This has been quite a significant change in our community. It's reflected internationally in the activities that have been and are being undertaken by agencies such as ESA and NASA to create climate data records, or the so-called essential climate variables. One example of this is the ESA Climate Change Initiative that's creating climate data records for a range of different parameters, including ozone, aerosol, greenhouse gases, and now water vapor, which I'm off to a meeting for next week. Creating these long-term data records brings challenges of cross-calibration and continuity. To study long time frame questions, you need to be able to stitch data together from different satellites and different instruments reliably. It's not just a single mission problem anymore. This need has led to a greater focus on international collaborations in space-based atmospheric science. For a lot of us, it began with working together with our European, US, and Japanese colleagues to understand the quality of data products coming from our Canadian satellite systems. And the collaborations developed further in order to utilize these data and merge them into multi-sensor data records. This international and highly collaborative approach for space is a second trend I see affecting our work in academia. It shaped our community to be well connected both nationally and internationally. We tend to be a small community, but we have a wide reach. We've been developing these extended collaborations over the lifetimes of CISAT, OSIRIS, and MOPIT. Moving forward, we need to develop follow-on missions and technologies that will continue the long-term data records of atmospheric composition that we need to understand our planet and how it is changing. And over the lifetimes, particularly of CISAT and OSIRIS, the number of satellites that provide complementary measurements has narrowed significantly. It's leading to what many years ago was called a looming gap. Now it's being described as a chasm for this particular set of measurements. That's one part of it, but it doesn't mean that we just want to consider continuing existing data sets that support our scientific studies. Canadian academics are very interested in ensuring that we're getting the best measurements. So that means looking at new technologies, new methods, new orbits. And we want to do these to do our best to characterize the Earth's atmosphere. So these are innovative ideas that we're bringing together with industry and government partners through technology development and mission concept studies to see how we can further and improve our measurements. For example, we heard that in the industrial side, thinking from going from GEO to LEO is where things are going. For us in the academic community, thinking about how we can go to GEO to answer different questions and look at different timescales has been happening in the atmospheric community. So thinking about being able to make measurements that we see a particular place more than once over a day, which we can do from GEO, allows us to look at things such as the evolution of pollution events. Now for Canada, having an awful lot of its land mass at high latitudes and a particular focus on the Arctic, having a way of making geo-like measurements of our country is important. And so this is where some innovative ideas in looking at using highly elliptical orbits and sets of measurements are being investigated from an atmospheric standpoint, and to provide complementary measurements to those that would be made by our partners in other countries, such as the US, in the European Union, and JAXA, as well as CARI. So to conclude, I hope I've highlighted 3 areas or trends for the academic community in the context of atmospheric science, which I think can be extended to other communities. The idea of looking at longer-term data sets, not just one-offs, to think about our mission records, definitely the importance of collaboration, and the need for continued innovation to further our utilization of space-based observation. Thank you.
Thank you very much, Kaylee, and thanks to all the speakers for their introductory remarks. So going back to the theme of this panel, to bring in various perspectives on the future of Canada's space sector, I think I'd like to bring a first question or a new aspect, and that is the fact that space is becoming increasingly commercial. We say space 2.0 now. So I would like to gather from each of you what is your opinion on how this can change and how this can influence the future of the Canadian space sector. So just to change things, we'll just change the order in which we ask the speaker. So I will start with Mike now.
Okay. So in terms of the world of Space 2.0 and the sort of the new economy that's evolving, we certainly agree that it's becoming more commercial. It's certainly becoming much more active. In terms of the impact of that, I mentioned previously in my remarks the business interfaces for us are dramatically changing from what used to be a lot of government or institutional type business interfaces. Those still exist, but now the increasingly commercial interfaces with international companies of various sizes, that now becomes much more popular. So it affects the business in terms of the business models that result and the commercial conditions that we do work under. The transition from the low volume kind of geo type work to the high volume LEO type work that comes with all of that activity and the commercial side of it, that's affecting our manufacturing, like I mentioned before. We're also seeing some pretty massive shifts in people's interest in information out of space, not just raw data anymore. So as more and more data becomes available, it's definitely shifting and creating more of a business opportunity in analytics and information products. So we have many more instances now where we work in partnership with people to use space data, but then analyze it and then just deliver the analytical output that somebody wants. They don't even want to try to process all the raw data we used to try to feed them. They just want the answer. And so the number and different types of companies that you can now work with to provide advanced analytics and information products around Earth observation data, for example, is proliferating greatly as a result of that sort of new economy that's emerging in Space 2.0. And the business power that comes with that. I've never lived the transition that went on in terms of the evolution of companies like Cognos and the like, and business analytics and bringing the whole world of dashboards and data to business leaders. But that must have been a similar transition, that now we see this in space with many more people just wanting to get that analytical output. The other big thing for us is the increase in venture capital. I was with some strong investors the other day. They run one of the larger space funds in the world. They have done an analysis that shows that the amount of venture capital in space firms in the last 2 years exceeds the previous 15 years combined in their analysis. Companies are looking at hundreds of VC venture capital applications a month to be able to sort through which ones make sense and which ones to invest in. So that's, will turn into dozens a month of people who are picking up money around the world. And so just this proliferation of companies and the complexity that brings in the marketplace is really interesting. It's interesting in terms of the number of firms you can work with now, but it's also interesting for companies like ours and to figure out, you know, what's real and what's not real. It's amazing to me how many conversations we get into around the world with larger corporations and with investors and with the larger government procurers, trying to decide on, you know, which of these initiatives, of which there are now dozens leading to hundreds all over the place, are going to catch, and which ones are going to be real, and which ones are going to convert from, you know, science experiment to business opportunity to sustained business over time. So that there's a whole new business analysis thing that comes into play now as you try to assess this market that is affecting the overall business dynamics that I think is really interesting, and that we're having to develop new skill sets in to be able to figure out who to partner with, which things to take advantage of as we move forward.
Thank you, Mike. Ewan, your turn.
Thanks, Jacques. Maybe I'll just touch on something that you just said, Mike, to start with, and I think it's really interesting. You talk about this increase in investment, dozens of companies potentially every month getting an influx of capital to be able to pursue their opportunity and turn it, like you say, from a science project into a business. Yeah. And one thing that I think that all of us in this room need to work on to some degree is the acceptance that the flip side of that is that there's many that won't be successful, or that will get some funding and then will work for 2 or 3 years and then they'll burn out or fight away and die. And I don't think that necessarily is failure. I think that can to some degree be seen as success. I think the investment that's made in that technology can evolve to something new in the highly qualified personnel that are involved in the projects. And the fact that, you know, there's more and more of these ones coming along, there's going to be more that are successful. That's great. You have to accept the bad with the good, and that some are going to fail. And that kind of ties back to another trend in this new space 2.0 phenomena, which is risk tolerance. And while people talk a lot about being more tolerant to risk, you know, when you've got 900 satellites in a OneWeb constellation as opposed to a single GeoBird, I think we talk about it, but it maybe isn't quite there yet. And we need to continue to work as a community to accept that risk and accept these failures and therefore move forward more aggressively as a community. I really think that we're in a transition period. So I've had kind of debates back and forth with people in the community about, you know, I would almost assert we're Space 2.0 isn't new space. It's now the established paradigm. But I don't think we are quite there yet. People go back and forth, and ultimately private investment is ramping up, and it's on track. I mean, we're still lagging the U.S., but that's not probably to be surprised about. But it's coming and it's growing, and you know, Mike just confirmed it with his comments as well. And in an age when the success of a startup really, in the early terms, is defined by how much funding they measure, the more and more of these that are quote unquote successful by getting this funding, you know, the more overall success we've got in the industry, which is a really good thing. You know, another example, or you know, a big part I see of what Space 2.0 is this idea of you know, government as a customer procuring data, like you said, rather than you know, a spacecraft. And that model is fundamentally different. And it's not just governments; it's all sorts of companies that are starting up that you know, can do great things with huge amounts of data. AI, machine learning, all these technologies need tons of data to be able to train their algorithms and test their algorithms. And then they need lots of data to be able to extract the information that they need, which is what they sell. So they're not selling the spacecraft, and they're not selling even the data. They're selling the information that they get out of it at the end. And that is the kind of new paradigm. And I think we're kind of part of the way there in Canada. And some of those examples have, you know, there are examples of that being the new model, but there's also still examples of the old model, and we're kind of in that transition period. But I think that because we're in that transition period, there's a really big opportunity for companies to disrupt. You know, at some point, new space is going to become old space, and the disruption will have largely occurred, and the opportunity won't be as present. And whether that is in 50 years or in 5 years, I don't know, but that will come at some point. So I think right now is a really big opportunity. And you know, as for to use mission control as an example, you know, we are trying to look at space exploration in some new ways. So we're looking at concepts like software as a payload or downstream space exploration. So these are ideas we've kind of formulated and pushed since our inception, and are things like using robotic telemetry archives to conduct science, or to leverage existing sensors with new algorithms to solve current problems. And I think, like I said, these opportunities they're still growing right now. There's more and more of them out there. There's more opportunity to disrupt kind of as we speak. And so I think now is the time to get on board, create that disruption, and then see where we end up in a few more years.
Thanks, Ewan. So, Kaylee, what does that mean for a university Space 2.0?
Well, I see this as a place for both opportunity and challenge. There's definitely an advantage of having more routes to get Earth observation instruments into orbit. Also, the ideas of having constellations of instruments or constellations of satellites providing us with increased coverage both give us some really neat opportunities in thinking in terms of increased access. Now, the utility is going to depend on the questions that we ask. Being a scientist, a university professor, it always comes back to, so what was the point of what we were doing? Now, we think about that in terms of questions, but we also can think about it in terms of services. And we need to match the platform and the solution to make the best use of the resources for our purpose. So the way I looked at this was to think in terms of some questions or some ways of thinking. So for a particular problem, what's our goal? Is it a science experiment? Is it a science data set? Is it a policy data set? Is it a public service? Or is it a commercial enterprise? Then thinking about, well, if we want to do this and have this constellation idea, how small can we make our instrument and still be able to provide the data quality that we need? Because at a certain point, maybe we get towards having a flying widget, which is neat for training HQP, but does it get us what we want to do, and is it the best use of our resources? So questions about whether it's nanoscale, microsat scale. Coming at this from a calibration and validation background, it's hard enough to keep calibration between one satellite and a friend. If you had a constellation of 20 different instruments, my mind is boggling at that challenge. How do we do that? We need to come at this development in a way that we're able to keep that cross-calibration between measurements. Because if we're trying to measure greenhouse gases and we're using it for policy, just because the instrument that's over your location happens to be measuring high versus the one that's over someone else's location measuring low, shouldn't mean that you should be paying a higher penalty than them. So the more instruments you have, the bigger this problem becomes. And so maybe we need to think about ways of merging ideas. So there's also the question of data density. Just because we could put up 20 microsats, does it give us the observation time series we need? Particularly on a policy level or on a service level, those have very different time scales. If it's a service that's going to tell us about what air quality is going to be tomorrow, your calibration issues are going to be different than if you're trying to build up a time series that's going to go generationally. So I'm starting to think about the missions that we need to keep the legacy that I've worked on going into the future. So how could we use new space to extend our time series and get the most out of our measurements? And this is where maybe we need a combination approach, that the types of things we've been doing primarily with government funding can be used in concert with new space ideas. So one colleague of mine suggested, well, what if we have one big satellite and a series of acolytes? Does that get us our cross-calibration? Does that get us the data set that we need? So I see this as an area of a lot of promise, and we need to work out some of the little niggly problems to get us the data sets that we need to get where we want to go. Thank you.
Thank you very much, Kaylee. So for you, Sylvain, does that change the role of the CSA, the fact of the rise of new space?
Well, in fact, I hope it does. Not as much the role, but more the way that we approach executing our mandate. For me, Space 2.0 is about a new level of activities that requires everyone to dial up their game. I see Space 2.0 as a reality that is here to stay. It will bring about substantial change for the long term. And if you're not sharp and you're not on top of your game, well, as was mentioned previously by Ewan, you're not going to survive. But I see Space 2.0 as a systemic opportunity as opposed to a battle of new space versus old space. The old space folks have been around for a long, long time, and they've learned to adapt. And they are adapting, and they will adapt. So I've heard forums where, new space is going to move old space aside and all that kind of stuff. Well, I don't see that happening. I see what's happening as the fact that there's been an injection of new ways of doing business, new business models, new approaches, new things that used to be reserved to government now being commercialized, and that's required everyone to sharpen their pen. And I see that as being the status quo going forward. So I welcome new space. It's going to require all of us, including government, to look at the new reality and look at how we can adapt to benefit from it. Clearly, from a government perspective, where we are, a large customer, I see the Space 2.0 as an opportunity to do a lot more things with the same dollar, because the cost of putting a kilogram in space is going down all the time and will likely continue to go down. A lot of the launch companies are actually now providing even cheaper ways to get and put things into space. So that means that we spend less on that aspect than we did in the past, and we put more of it on a different diversity of missions or more expensive missions going forward. As Ewan also mentioned, it does bring about a new approach to how we look at satisfying, say, government mandates. So in the past, where we could have been tempted to believe that only government is in space, so therefore if we have a new need, we must put a satellite in space. Today, the reality is much different. So let's not get tempted at first glance to go and put some new hardware into space if someone else on the commercial side has already taken that risk and is looking at leveraging the cost of that operation over multiple customers, government being one of the many customers. So that whole idea of now buying the data in the future, buying the data as opposed to owning a satellite is going to be quite interesting. Now that being said, and back to my comment about old space and new space, the idea of buying data instead of owning a satellite is not new. In fact, we've done that for RadarSat 2, and we've been doing that for many years. So, probably groundbreaking in its time, but it's something that's been very, very successful to both MDA and into the government. And looking at, what Space 2.0 will do is it will probably give us even more opportunities to do and to engage into more strategic relationships and more, innovative PPPs, public-private partnerships as we go forward. So I see Space 2.0 as a real great opportunity. Fully embrace it, welcome it with open arms, and look for the opportunities that I think are going to be beneficial to the space program, but also to Canadians at large.
Okay, thank you very much. My next question to each of you is basically, what is, in your view, the place for Canada in the space sector in general? And I would like now to start with Ewan. Go first.
Okay, so I kind of take that question to some degree to be focused on what government's role should be in terms of what's the place for Canada. And the reason I take it that way is as we've seen, private companies, industry will do what they think is best to achieve their objectives. So an example is MDA and the lots of changes we've seen there. And like you say, it's a strong, proud Canadian company, but there's been changes in the structure, and that's because that's what you need to do to adapt. And I think that applies to new space, to old space, big companies, small companies. We're going to do what we need to do to survive. And so in terms of where does Canada go, what leadership do we need? That's something that I think that has to come from government. And I think, first off, it's easy, so I'll just say it. I think definitely the government needs to establish the appropriate regulatory framework to facilitate what are rapidly evolving business models of new space. So I think, without government action, quickly and in the near term, new space companies may have to adapt and go elsewhere if this is not the right environment for them to operate. I think, but beyond that, beyond regulation, Canada really has an opportunity to be a bold leader in space. I mean, I think we have all the capabilities, both in industry and in academia, and kind of sitting on both sides of me here, to lead and operate a completely bold and novel space mission, as a country. Something that could inspire our citizens, and really at this time of kind of international strife around the world, bad news every day on coming from everywhere. I think we could use that. We could use a little inspiration in our lives, and a big bold mission doesn't necessarily need to be space exploration. It could be telecoms, it could be EO, it could be whatever follows on to RCM. But I'll throw out a couple of examples on the space exploration side because Mission Control is a space exploration company, and because I think these are ways that Canada can signal to the world and can inspire the next generation here at home. So one thing I saw this morning on Twitter, a tweet from Mr. Leclerc about a Mars sample return fetch rover. And I think that's amazing. That's spectacular. If Canada builds a rover that is involved in the process of bringing back our first material from Mars, other than meteorite debris, that would be an amazing coup. And that would position Canada to be able to continue to have a seat at the table in terms of guiding overall international space policy and space objectives. I think if we continue down the road that we've sort of slid over the last few years, we have less credibility in terms of guiding, the international community in terms of space. So, I would also look at the cancellation of the Resource Prospector mission in the US as a potential opportunity for Canada. I think there's lots of opportunities out there for us to do something big and bold. And I think we need to sit on or leverage our main strengths. And when I look at Canada, I think of science. We just had a great announcement in the budget for all sorts of science, and I'm excited about that. I think it's excellent. I wish it was coupled with the same amount of money for space, but nonetheless, let's think about it from the science perspective, and let's think about this government's interest in the environment. Well, right now we've got companies like iSpace, Deep Space Industries, Planetary Resources, Moon Express, and on and on and on and on, as well as governments like Luxembourg and other places who are talking in the very near term or medium term going to mine asteroids in the moon. Well, when we're going to go up there and do that, who's thinking about sustainable exploration? Who's thinking about the environmental side of things? Maybe that's a place that Canada can take a role, a leadership role. But I think we can only do that if we actually are involved and have a seat at the table and aren't leaving it purely up to private industry to support. So I think the Canadian CubeSat Challenge is for the students is an excellent program, and that's going to fill this pipeline of talent that we need. And now we need to evolve that bigger to a kind of a government and industry level mission, and something that will inspire the world.
Thank you, Ewan. So, Kaylee.
That's a little bit hard to follow, isn't it? I like your vision. I agree that we need to think in terms of our strengths, and we need to think about where we can go to make the biggest bang for our buck. We have this great heritage, we have lots of expertise, and we have experience, particularly coming from where I do on space science and engineering side. And if we use that to identify what we can leverage and where we can go, I think we've got a lot of possibilities. I'll give you a couple of examples, particularly from the SciSat and OSIRIS mission perspective. Right now, these missions are unique in the world. Their data set that they provide is making a significant contribution internationally. SciSat was launched with 14 species that its baseline for measuring. At the moment, I believe more than half of them are not measured by any other satellite sensor. So we're providing a very significant contribution. It's because we measure some esoteric things, but they provide the background that we need to understand the change in our atmosphere. We also use a technique that's called limb sounding. And limb sounding provides us with profile information about our atmosphere. In the general space sense, from the other agencies, a lot of focus, particularly in Europe, has gone towards services that require high spatial density of measurements. Limb sounders don't always provide that. And so the focus has been away from providing this critical set of measurements. So right now, we're holding up our end. But there are no new missions using this technique in development anywhere in the world. And so I think this is an area where we could make a strong and recognized contribution to the international data pool. We have a great pool of data, particularly in the atmospheric side, where it's not the same model as RadarSat. The Canadians put in their data in one area of atmospheric science so that the weather people can take out data in another area. And so this really fits together in having a contribution that we make internationally that allows us access into that. And so I think we need to continue to think about how we continue that, particularly for academics, where we don't have high degrees of funding, so paying for the data that we need becomes difficult. And so thinking about how we manage that in our new space / old space context is going to be quite important. So I'm going to leave it there and thinking about a couple of those different areas and how we can think big and go from there.
Thank you, Kaylee. Sylvain, what is your own response?
Well, you know, when I see the question, what is Canada's place in space, there are many ways to answer that question, and I'd like to take the dimension of the international perspective. Also because I've accumulated dozens of international conferences and seen firsthand how Canada is received by our various international partners, and I'd like to share that with you. I think what's very, very important for us to realize that Canada is in a leadership position for space, point blank. If you ever doubt that, start talking to your international colleagues and they will echo the same sentiment that I have observed and witnessed internationally. Canada is a trusted partner and we are sought after. Now, why is that? You know, we take a lot of pride in knowing that. Many of you have echoed that and shared that opinion with me, but why is that? Well, I can tell you that it's certainly because of the success we've had in a number of missions, but fundamentally, what makes this country so interesting from a space perspective is the depth that we've got, right? So we have very, very strong, internationally recognized universities, post-secondary institutions with a fantastic cadre of professors and researchers in those universities. That gives us depth. We've got tremendous experience and very successful Canadian companies as well. We've got great associations, and we've got the CSA that also contributes to that, right? So when you look at what makes Canada so great and why are we in a leadership position, it's all of those things put together. So all of us in one way or another contribute to that global success. So we are sought after. I'll share with you something as you know, particular or tactical as a traditional schedule when I go to an international conference, just to illustrate you know, Canada's position here. I would have somewhere in the vicinity of 40 to 50 meetings in a period of 3 days. It's kind of a marathon when we go to these things. Of those, the majority are countries that are looking for opportunities to collaborate with Canada, right? The other meetings that I would tend to request would be where we see an opportunity for, you know, a Canadian firm or a Canadian university to participate in something that other country is doing. And when we do request a meeting with that country, we never get a no answer. We always find a way to meet with them. So when you look at that kind of a schedule makeup, it speaks volumes to the fact that Canada is very, very popular and a sought-after participant or partner in these meetings. And when we do get approached to partner, Clearly, our track record in terms of what we've contributed for the different missions serves us well. We've always delivered successfully, and usually on time, if not ahead of schedule, as was the case with James Webb. But we also are very sought after for our scientific community. So in some instances where we could not or didn't desire to be part of the hardware providing team, we do get requested very often to see scientific collaboration from some of our eminent scientists in Canada. So one way or another, we find our way involved into many of these different missions. One thing that's also very interesting, you're all aware that the number of countries involved in space is growing very, very fast, up to 80-some countries now at last count and growing. Many of those countries are developing economies, and invariably, most of them come to Canada for coaching, for advice, for consult and whatnot. They see us as one of those approachable countries that you can go to and you can get some help and you can get some support from Canadians. And it's something that we've been encouraging internationally, this leadership role that we've got. And again, in a very Canadian way, very quiet, but very unassuming, very quiet, but very effective. And it's been in high demand out there. So in terms of our place, in space, we're up there. We may not have the budgets, we may not have the economy that some of our larger partners would have, but we clearly are a very influential player out there.
Thank you, Sylvain. So, Mike, what's the place for Canada in your view?
I agree with the comments that Canada is in a position to be a leader. Canada is a leader. I agree with that historically, in my view of these things. Third country into space, is in the inner club as a result of those decades of being part of that international community. You see that everywhere you go when you travel around, the world. I think that the key thing at the moment is to try to see to what extent we can kind of hold that position going forward. You mentioned that the transition between old and new space, that we're kind of in this transition, and we are. So we still need institutional projects. We still need larger missions. Those tend to be government funded to be able to engage the base, while that base now has even newer opportunities to start to participate in more commercial activity in space. But we probably need both sides. At a time when there's 80 countries setting up interest in space, and they are coming to Canada for advice and guidance for sure from the government, they'll also come to Canada for their industrial capacity and smart people. And so, folks like us would be in conversations with those countries to say, being invited to come and set up shop and extend our reach to participate in their space programs, because they want to get into space and they do recognize and welcome that experience. For me, it's a critical time to make sure that we are still continuing our legacy of doing solid anchor, larger programs and missions that do develop more of a strong business base than just the government leadership and academic and science leadership base, which is super solid. I agree with that all the time. So it is a critical moment. I think everyone's kind of watching that space right now to see, Sylvain mentioned when he started speaking that the world of space exploration is returning to the table to figure out, how's everyone going to play together. And as we go into deeper space exploration, it'll be really interesting for Canada to see how Canada shows up in that adventure. And for me, it's interesting that for Canada, it is a source of pride. And when you talk to Canadians, for those that are aware of space, there is that awareness issue that someone mentioned on his flight here this morning or yesterday. But those that are aware do have a strong source of pride. It's interesting to see the other countries in terms of their understanding of the economics of having a strong business based on space. The UK space strategy, for example, is not based on space sovereignty. It's not based on key aspects of a space exploration or an astronaut program. It's based on economic development. Like when you talk to them, like they want to create an economy in their country because it's high quality jobs in a new economy that's emerging in space, and they want to be in, and they're going to build a space strategy based on that. It's interesting for me to bump into the number of countries that are talking about that and really seem to understand that. I think we have to work a little bit stronger probably as a gang to make sure that Canada writ large understands the economic value of a strong space economy at a time when there is such a surge coming in economic activity that will be going on in orbit around the Earth. So I think that we have to help people understand that. We have to have the government anchor programs to hold us there, and then continue to work as a community to take advantage of that.
Thank you very much. The last subject I'd like you to touch on is the subject of collaboration. So how does collaboration have to develop in the future to take advantage of the opportunities and proceed and improve our performance in the space sector? So for that subject, we will now start with Kaylee.
Okay, thanks, Jacques. I'm glad that I get to start off the discussion here because this is a topic very dear to my heart. I think one aspect we come at it as within academia, we have such a breadth of experience and expertise that we're really not just a set of data users. Most of us really like to stick screwdrivers in things, look under the hood of any code just to see what's going on. That's what makes us scientists and engineers. And one of the things that I think we can benefit from is to try and leverage that much more strongly than we already have. As I mentioned before, within the Academic Atmospheric Science Community, we have 3 missions currently in operation, and they have been for more than a decade and a half. So let's think about what we can do with this experience in mission development and instrument test, taking us all the way through to data utilization, and figure out how we make the partnerships that we need to utilize this. We got to this position where we are in academia for a lot of us through collaboration with industrial and government partners. That's how we got our missions into space. As we look towards the future ideas, a number of us have been involved in STDP and capability demonstration projects. You're going to hear about some of them this week, as well as concept and mission development studies with partners both within Canada and outside. And so it's a matter of taking this existing expertise and experience and really pushing on what we can do, because we want to further the overall goals for Canada in space. Now, I think another component of this is not just collaboration within Canada, but is the need to do this internationally. As Sylvain mentioned, Canada is often approached to be a partner in things. Throughout our collaborations, both nationally and internationally, it's often the academics who are at some meeting who start talking about some idea, and then that sort of goes out to, oh, we have this possibility, we have that possibility. And so making sure that when we find these opportunities, or there's the possibility of an opportunity arising, which I know sounds very convoluted, but often we know that's how it works, thinking about how we build a system that allows us to capitalize on them. Often different countries and different programs have very different timelines. And so making sure that when an opportunity arises, that we've got partnerships in place, we've got access to the different components we need to be able to step up and say, yes, Canada is willing to do this, Canada really wants to do this, and this is what you need from us because your mission will succeed because of that. So I'd like to throw it to the others from there.
Thank you, Kaylee. Sylvain, your turn on collaboration.
Collaboration is a subject that we often talk about on panels, and there's a good reason for that. Is because it's absolutely critical. It's critical in many, many industries, but I think I've never seen, having worked in many industries, clearly it's more essential in space than other industries that I've seen. Is it a question of maturity or not? I don't know. What I do know is that space, given its very demanding situation, requires the collaboration of many folks and many entities for it to be successful. So when I look at collaboration, you do it for some economic reasons, that's for sure. And when I look at, historically where the CSA has invested a lot of money, we always look at the leverage effect of collaboration. In many cases, we cannot afford to be the single provider for a particular mission. So then we have to look at how can we leverage our international participation. And we do that for cost and risk-sharing reasons, and I think that's very logical. But another aspect that's also just as important with respect to collaboration is the diversity that it brings, right? So, you know, space is bigger than one individual, bigger than one company, bigger than one country. You've heard that very often. We need to find the international collaboration opportunities to be successful out there. And I think that diversity the diversity that this collaboration brings is essential to our success. And with diversity comes, you know, different approaches in terms of problem solving, or different approaches and ways of looking at problems, and different areas of creativity. So when you do collaborate, particularly from an international perspective, that diversity is absolutely essential going forward, and it brings about a tremendous value add. To a point where when I speak to students, I invariably get the question of, you know, what would be some of the skills that would make a student successful in terms of their career in space? And I do know there's quite a number of students in the room today, so welcome to the session. So, but I'm not addressing this just to the students. I think it's something I want to share with even those of us that have gray hairs in the room here. But, you know, typically when they ask me how can one be successful in space, I say, you know, you need to master 3 skills. At the beginning of the career, you need to master your technology, whatever that is, right? You need to demonstrate that you are very strong in your area of expertise. So that goes without saying. But then as you develop that skill and you get a bit more senior, you have to develop your marketing skills, right? The greatest idea without you being able to sell it is not gonna go anywhere. And I'm talking about selling it, if you're a junior person, a junior engineer, a junior scientist, selling your idea within your company, within your organization is hard enough. Try selling it to international partners. So the whole marketing aspect is a skill that needs to be developed. But really the third element that I bring about, which is germane to this subject, is all about collaboration, right? As an engineer, as a young scientist, you need to develop those skills. And collaboration is hard. We've all been there. We've all had to work with people that, you know, even in our own company, we've had to work with people that we don't like. But they add something, they add value to your project. So you need to find a way in your human behavior to eke out the benefits of working with everyone in your own firm, so that as you grow more and more senior in your firm and you start to collaborate with other firms and you start to collaborate internationally, those skills will serve you well. So clearly collaboration needs to be one of those skills that you develop. And I think the fact that we talk to students that way, because we see it as one of the fundamental development pieces for their success, it also applies to all of us.
Thank you, Sylvain. So, Mike, I think you have some very specific things to mention about collaboration.
Sure. It's obviously essential and important for us. For me, as being a bit of a larger company in the sector, you get into different levels of collaboration. So I feel like, you know, I have to collaborate with my customer base. I have to collaborate with Sylvain and his team to be able to even help, you know, shape and cause the future of programs in Canada, or with General Wales and Director General Space and his community as they try to implement strong, secure, engaged, and the very strong space elements of that to try to realize that. So I think that's interesting. When we then go international, though, I think there's a collaboration that occurs there in terms of making sure that what we're doing with other countries is in line with the interests of Canada and those collaborations, so that we don't disrupt those, that we only encourage them and enhance them. When we have programs in Canada, there's obviously the natural collaboration that occurs where corporations get together and or with academia to build teams of people to go after a program. I think that's been the MDA's history. In the industrial collaboration side, it's really when there's a program that needs a team, you build one and you go. But now I think with the evolution of this sort of newer economy in space, and the realization of the bench strength across Canada, I think we're going to change ourselves a little bit more to emerge a bit further in terms of having more persistent collaboration from a market perspective. So as part of me coming into MDA, one of the things I'm going to start to do is create this thing called MDA Launchpad, which will be like a small to medium enterprise interface to MDA, and then there'll be a full-time senior leader that's responsible for that who has direct access to me. And so that this will be like a senior person that knows everything going on in the company, so that there's a place where anybody from the outside can come and interact with our larger corporation to be able to talk about what they're trying to accomplish, or how they could collaborate with MDA, how we could help work together back and forth to create a bigger opportunity. I think that's important now, especially with the diversity of and the increasing numbers that we talked about in these small to medium enterprises. So we're going to try to change our structure and interface as we go through the summer and get this thing staffed and launched by the time we come into September, so that we've got that persistent interface to small to medium enterprise to include in our projects or our programs moving forward. Because there's so much you're doing on the bigger programs, you can cause a lot more collaboration that you don't necessarily need the team on the program, but I think if you set yourself up well in the marketplace, then you can do that, because you're always designing a new capability. We're always launching something somewhere within MDA or Maxar. There's always rideshare opportunities. We're putting ground stations in all these countries. Somebody's always building an algorithm that we could have as an upgrade on our ground stations or what have you. So I think we have to open up that portal and staff it and make it persistently available to get more collaboration, because if we don't structure it, then it won't happen on a systematic basis.
Thank you, Mike. I think that's a great initiative. So Ewan, you have the final word.
Okay. I think this one makes it easy for me to be the final word, because everyone has said all the great key points. I'm in 100% agreement. I think for space in particular, like Sylvain says, collaboration is essential. And another thing that is worth pointing out is that for niche players, which I would say Mission Control, my company is very much a niche player. We're not trying to do everything. We're not like SpaceX that's vertically integrated, or now Maxar that's vertically integrated. And so we inherently need collaboration to survive and to function. And I think Canada's really good at it. That's demonstrated, like Sylvain said, in terms of his going around the world and meeting people all over the world that want to work with us. And that's, I think because we are so good at this, and that we have these programs in place to have all the levels of the space sector working together. And I think we need to continue to leverage this to do more, and I think we are. A couple examples that have come out fairly recently that I would kind of argue are more in the collaboration domain than in the procurement or grant domain are the Innovation Solutions Canada program, or the IDEAS program on the Strong, Secure, Engage side. And these are ways where government can collaborate with industry through an investment to allow them to grow a technology and then subsequently commercialize it, much like an SBIR program in the US. And I think these are the kind of mechanisms that really encourage companies to innovate. And of course, on the university side, I think it's absolutely essential. As a company, I don't think we've ever undertaken any technology development project without a partner at a university. And overall, I'd say Canada is a great place to start a new company, and a big reason is for the potential for collaboration. And I mean, obviously, it shouldn't be a surprise, but I'm extremely excited to hear about MDA's new launchpad. That's the kind of stuff that we like to hear as a niche player that would love to work with some of the bigger companies.
Okay, thank you very much. I think this panel has been excellent at keeping time.
That's a goal. It doesn't matter if there's any information as long as you get done on time. That's the main thing.
I think we're ready to go on tour with this panel.
We've met requirements.
Okay, so having done so great, we have a few minutes for questions. I would like to open up, and to anybody who has a question, I would like people to name themselves first, and then go with their question. And maybe if it's targeted to someone.
Good morning. Am I on here? Yeah. I'm Harry Cole. I'm the principal of the Royal Military College. First and foremost, thank you very much for your presentation, for your perspectives. My question revolves around cybersecurity. Last year at RMC, we created a chair of cybersecurity. There's a growth in the interest of cybersecurity, and not just at RMC, but universities, many universities have increase in growth of research and in teaching. Now, Ewan talked about accepting risk, and so I was wondering what your views on cybersecurity was. Is this in the category of accepting risk, and the nexus is not just secure networks or intellectual properties, but are there specific trends in the industry that are underway because of concerns for cybersecurity?
Okay, someone wants to take the question first.
Well, I guess I could risk an answer. Well, Harry, I think your question will be very appropriate to Brigadier General Whale tomorrow or Thursday. I think there's a. So hopefully you're still around, and I think he would have a lot to say with respect to cybersecurity. But nonetheless, even from the Canadian Space Agency perspective, we see it as one of the very critical areas where we need to demonstrate and operationalize as quickly as possible. It is the threat with respect to cyber attacks is increasing dramatically all the time. It's been an issue for years, and it will continue to be a challenge for any nation, and not just from a government perspective, but also from a private enterprise perspective. So it is an area of growth, and with respect to what the CSA can contribute from a peaceful perspective, because that's our business, right? It's a peaceful use of space. We are looking at developing or demonstrating some technology with respect to quantum use of keys and encoding on an initiative called KeySat, where we're working with some of the leading world scientists in this area in Waterloo. And we're now looking for an industrial collaboration with respect to some company working with Waterloo to put something in space so that we can test the concept. So although cyber could be construed to be very military oriented, I'm just alluding to the fact that it's also very commercial oriented. And even from a peaceful use of space perspective, there's some interesting technologies that we need to develop and need to prove and need to operationalize so that all of us can look at benefiting from a less threatening environment going forward.
Okay, next question.
Good morning, everybody. My name's Chuck. I'm a writer. Some of you subscribe to my service. My question is primarily for Sylvain. It's relating to the Canadian CubeSat program. First off, I think it's a wonderful program. It's great for capacity building. It's great for building a skill set. But maybe I'm wrong, but I looked through it in some depth. I didn't see Kepler Communications participating in any way, shape, or form. I didn't see Telsat really contributing in any way, shape, or form. It struck me that those are the two Canadian companies that between them are building a couple hundred really small satellites over the next little while. They would be the absolute best partners for the program. I'm wondering if I'm wrong and they are contributing, or if they're not on the program yet, are there any plans to bring them aboard over the next little while?
Good question, Chuck. I think it's a question of what were our fundamental objectives as we put the program together, as we designed the program. And as I alluded to earlier, we did not provide all of the means for a university to develop their CubeSat as they go forward, and we also did not dictate what kind of payload they should be interested in. So they've picked different subjects, they've picked different payloads, they've got different interests, and we were not prescriptive there. We left it absolutely open. So because that was our objective, to let them decide what they were going to put forward, we did not secure partners and whatever. And because we've also, as I said earlier, because we've also provided sufficient funds to get them started and give them critical mass, it's not 100% of what they're going to need to be successful, because we expect them to engage with the different partners. And I fully agree with you. We've got some great companies that they can partner with, and we're kind of looking forward to them approaching the industries out there and asking for those partnerships that I think are going to be essential, if not key, to their success going forward. So we did not establish that prescriptive design in our program from the onset. This was planned that way, to let them build up their partnering skills.
Thank you very much.
Hello, my name's Ken Radziniak. I'm from General Wales staff, but my question's as a private citizen. And it's first, I'd like to thank all your the panel members, and I'd just like to jump on one of the things that Mr. Reid said. So, Ewan, you mentioned briefly that how Canada's government could take a role in setting a regulatory structure for business. I guess what I'd like to ask both yourself and Mr. Greenlee and the entire panel is, would the existence of a federal plan or a space plan or a space strategy actually set the conditions for some of that for business and academia to know where to direct your efforts?
Thanks, Ken, for the question. And I guess first off, I'll say that I kind of made the comment about regulation more to reflect, I think, what is an industry trend in new space than just mission control. I know it's a concern for some of the other companies operating here, and I think people have probably heard, some of Planet's plans and challenges that they've faced, and maybe that's not quite regulatory, but fits in there. I think absolutely Canada needs to have an understanding, the industry, the community needs to have an understanding of where we're going. We need to have a strategic plan. And something Sylvain did when he started, I think a great thing in my opinion, was bring in a whole bunch of policy people. And so I think a strategic plan that's founded on solid policy would inherently recommend the right regulatory framework. And I think it's a big challenge because we don't necessarily know how it needs to look. And right now I might present a business model to an investor and it might look one thing and need a certain type of regulatory environment to allow it to proceed. In 6 months, the business model of the next company that stands up there and presents might be completely different in terms of what they need. So we need some adaptability, but I think what you're kind of implying is that if we had a big long-term strategy, that would then encapsulate and provide the framework to be able to adapt and build the policy, the regulatory framework as required. Yeah.
I'd agree with that. Like anything in business, to get velocity and to get people to commit and to cause things to move, anytime you can have some form of predictability, then you're going to accelerate that whole process. So if there is a strategic framework for anything, it's going to bring more velocity. It's going to bring more commitment, the opportunity for funding, the opportunity to frame regulation in any country. I think we'll start to see that in other countries as they're identifying in their space strategies, and there's a number coming out as we go through the next 6 months. Where they're picking their 3 or 4 or 5 areas that they want to focus on, and then they're lining up their budgets and they're lining up the regulation around that, and they're getting themselves organized. And when you see that, then industry can commit and participate in that much more effectively because it's a bit more predictable. You don't want to sit there just festering in ambiguity. You want to understand where you can play. So for sure.
And within
Thank you. I think we'll take, you want
Can I
to?
do one more thing? Within the academic community,
Yes.
we do things slightly differently than business, but having that idea of where we're going is important. But also, I believe there has been important consultation, and a number of the communities within academia have gotten together in the last year to be able to provide input to the space agency, to be able to say, these are the things we are definitely interested in as part of a process.
Cool.
Okay, thank you. So we'll take a last question.
Mark Boucher from SpaceQ. My question is primarily for Mike and Ewan. Mike, in your remarks, you said VC funding in the last 2 years was equal to the last 15 years combined. I'd point out that a good portion of that was money to SpaceX. But in talking about VC funding and the future and innovation in Canada and the investment community investing in Canadian companies as opposed to the government investing in Canadian companies. We've seen Kepler get some money, but that came primarily from the US. Mm-hmm. We've seen Skywatch get some money that included money from the US, but also some from Canada. In reality, when we're talking about this type of investment, mm-hmm. funding coming from the investment community in Canada, where are we at? Are we going to see And are you hearing about the opportunities that are going to be there for new space companies to actually be able to pitch and actually get some funding?
So for me, and the numbers I was quoting and the stuff that I was throwing around there was definitely from international studies. So that was definitely not Canadian based. And I agree that the bigger funds in this area have historically been outside of Canada for sure. They've been in Europe and some in the United States. Some of the more international funds that were constrained to Europe, for example, in their next round are detaching themselves from constraints that would hold them in Europe and focusing on North America and Asian companies as their next targets for venture capital. So I think that does open up the opportunity for more Canadian participation in some of those international funds. So I think that can come. In Canada, in terms of what's the state, you probably know better than me, so I'll let you talk about that. But I do agree that, like you did mention that one creative disruption thing. There is some early signs. I was aware of that as well. There's some early signs of interest in folks in Canada of starting to target funds, but it's early days. But go ahead.
Yeah, I mean, it's worth pointing out too. It's not just SpaceX. SpaceX's first round I think was 61 million, and iSpace's first round a few months ago was 90 million. And to me, that's a trend that's going in the right direction. And also, what's worth noting is iSpace not in the U.S. and they're in Japan. And I think that money came from a couple different sources. Another thing I think worth noting, right before I answer the question, is that Canada, I think, is actually an excellent environment to receive funding in other ways than venture capital or angel investment. So we've got a myriad of programs from IRAP, but Space Technology Development Program, and you go across the board, BDC, EDC. There's lots of mechanisms to get money in Canada, which is excellent. I think we're far ahead of many other countries out there. On the VC side and the angel side, which really is critical to this rapid growth of new space environment, we're not quite there yet. And I know that Mina, CEO of Kepler, made a lot of trips to the U.S. and really did not get much traction at all in Canada. But I think with creative disruption and with these first few with Skywatch, with Kepler, with the other examples, that's a validation. And so now VCs and maybe Canadian investors are going to be less likely to shy away from space, which maybe was still a bit of a new paradigm and a bit scary and risky and for them and things like that. So I think it's coming, and I don't know how quickly, but I hope relatively quickly.
Okay, thank you. No other response. Okay, so I think we'll stop here. I want you to join me in thanking the panel. I think you did great. Jeff, you have some.
Thank you, panelists. Thank you, Jacques. Just before everybody breaks, I want to plant a couple of thoughts in your mind. One is to point out the message that this slide that's been up here all morning is conveying. It's a message that all conference organizers try to implant in the people who are here. It's really, really important that the organizations that support this activity from which we all benefit play a role, an important role. And I'd like to thank those companies that are up on the screen with particular emphasis on ABB, the host organization here in Quebec City, and that's provided all kinds of support. And I'd also like to thank the agency. You don't see CSA's logo up there, but you probably should. The agency has done everything it possibly can to participate in this event, to provide content, to send its people, and to have all kinds of input and constructive contributions to the breakouts as well as the plenaries. So I want to give a round of applause to the CSA. It's important for them to participate. So a couple of quick things. First of all, thanks to our sponsors and our exhibitors. There's some exhibits out in the hall that I'd encourage you to stop and chat at. We're going to break for coffee. We'll reconvene at 10:30 for the CSA Directors General panel. I would ask the DGs just to convene back here not later than, say, 20 after 10 so that we can get you mic'd up. I'd ask the current panelists to not to forget to leave your mics behind, so we can do that. Then after the DG panel concludes at noon, everybody breaks for lunch. Lunch is on your own. And we should all get back here wherever we do choose to go for a bite to eat at lunch. Please be back here at 2 o'clock so that we can get the 6 breakouts underway. Again, I'll remind you that 5 are on this floor, and the breakout in the Wolf Room is on the 3rd floor. Following the breakout sessions this afternoon, we'll have the welcome reception. That will take place in the foyer here. If you have any questions or concerns, the administration room is the Buade. It's just across the hall here, and I'm here to help as well. Thank you all once again for coming, and I look forward to spending some time with you this week.